What are those attributes? That cost, size, then gain, bandwidth, and profile. Or there are 11 properties that we studied for antenna. Now, how many useful or how many popular antenna designs are there that we have to study first? So the first category of antenna is a wire antenna, and second one is a aperture antenna, depending on the structure. Means in a wire antenna, small wire we are going to use for a design of antenna. Wire antenna provides wide beam width. This is very important. In a small package, that means low cost. Because remember that your last product applications is depend on a cost only. So it is very popular. We are going to study what is a wire antenna. In a wire antenna, dipole antenna. This is a wire antenna. Wire antenna means just a wire which is going to cut in the middle here, and यहाँ पे जितना उसका length है, same length यहाँ पे है. So this is your dipole antenna. This is your characteristic impedance Z0, which is going to connect by your transmitter or receiver and antenna for maximum power transfer theorem. Why maximum power transfer theorem is important?
Maximum power transfer theorem is like load का जितना resistance है उतना ही source का होना चाहिए.
Okay, very good. Why?
Efficiency ज़्यादा होगी फिर.
Very good. Quality factor is more, efficiency is more, and maximum power transfer तभी होता है by observing that graph. This is my dipole antenna. Then this is my characteristic impedance, transmitter, receiver. This is a dipole and this is monopole. In a monopole, one terminal is a grounded or balanced antenna and unbalanced antenna. So dipole antenna is a balanced wire antenna. Why? Because both the ends are having a similar length, okay, same characteristics, and this is an unbalanced monopole because one terminal is the grounded. The first question, why wire antennas are so popular? So there are two reasons. First, that they are rarely cheap and it is a azimuthically symmetric. So first, cheap means the cost is very low because it is simply a straight piece of wire. As a result, it is inexpensive to manufacture. Means directly you can take a simple wire, उसको cut करो बीच में, and you can prepare your own dipole antenna by connecting wires. Now, the azimuthically symmetric means what? This is your y-axis and this is your z-axis. This is your x-axis, and this green is your dipole antenna. So the antenna is oriented along the z-axis. Now observe, if we rotate that antenna, means from z, I'm going to shift that antenna to y. What is going to happen? It's the shape of antenna or any characteristics are going to change because it is a simple wire. Now imagine if there is a horn antenna, and if I move the horn antenna, then what is going to happen? And if I am going to move a simple wire, then what is going to happen? So if this is my dipole antenna, the wire is a circular cylinder. This is a basic thing, that wire is nothing but a circular cylinder. Cylindrical symmetry. We know that the coordinate system, cylindrical symmetry means what? Rotating this cylinder in an azimuth does not change the structure of antenna anything. So structure of antenna is not going to change. That's why I said you imagine that there is a dipole antenna, and same thing, imagine there is a horn antenna. For a dipole antenna, the symmetry is not going to change, or the wire cylinder has no referred or unidirection with respect to theta, every dielectric. Okay, so the gain pattern of azimuth is a 90 degree, that is a perfect circle. So that's why if you observe the gain pattern, so it is a perfect circle, and in other words, it is a radiation pattern of which antenna? Isotropic antenna. That isotropic antenna, the first ideal antenna, which says that the radiation pattern is a perfect circle. So in other words, क्या wire antenna or the dipole antenna will radiate equally in all azimuth direction? Phi? कि अब अगर mathematically it is proved that कि dipole antenna is going to transmit circularly, means radiate equally in all direction. So is it an isotropic antenna? Perfect isotropic antenna? But what is the main problem? That isotropic antenna is ideal. So it is not possible, it is impossible. Okay, meaning the wire antenna is of course not an isotropic radiator. What is a Radiation pattern of dipole. It is radiate uniformly in elevation direction theta. So azimuth symmetry is a one reason why wire antennas are popular, and azimuth symmetry. So for broadcasting and mobile application, this is a very important application for antenna. We don't know where the receivers are located. हमें पता होता है क्या कि कहाँ पे रिसीवर होने वाला है? आप ड्राइव कर रहे हो on a highway, if you are sitting in a home or wherever, so we don't know actually where is the transmitter is there. मीन्स आप कहाँ से बात करोगी, वो मोबाइल कम्युनिकेशन में कभी भी या ब्रॉडकास्टिंग में वी नेवर प्रेडिक्ट द लोकेशन ऑफ अ ट्रांसमीटर और रिसीवर, बिकॉज हम लोग फोन पे बात भी कर रहे हैं और सुन भी रहे हैं. सो योर फोन इज अ one time it is a transmitter, and when you are listening it is going to work as a receiver. We don't know where the transmitter and receiver. Similarly, when you are talking on a phone, आप क्या कर रहे हो, आप चलते चलते बात कर रहे हो. So what is going to happen? Your location is moving. Or if you are in a car, then what is going to happen? You are moving at least 40 kilometers to 60 kilometers. So location is not a fix. This is very important criteria when we are studying communication system. That it is very easy to say that I am getting a high signal efficiency or clarity, voice clarity अच्छा है highway पे, but what is your speed? It is above 100 kilometers. At that speed also antenna should support your transmission system. As a result, we need to transmit or radiate across all azimuth direction. This is very important, and if possible note down that reason, that why we need to radiate across all azimuth direction and which application it is very essential, or receive equally well from any or all direction. Otherwise what is going to happen? You are going to missing the data or call drop or some beach mein you can't listen the voice of that person. For dipole antenna, length L oriented along the z axis and center at z is equal to 0. So z direction with amplitude which closely follows the following function. So this is a formula for current where it is 0 to L by 2. The formula is I0 sine bracket K L divided by 2 minus Z, and when length is L2 to 0, this is current distribution. So this is your current distribution for your length of antenna. This is, if this is my feeding point, okay, then your current is this, or this is my feeding point, then your current is. Before examining the fields radiated by a dipole antenna, consider the input impedance of a dipole is a function of its length. It is very important, because when we are finding a current, what is the formula for current? V is equal to IR. Impedance is very important and it is a function of its length. That's why if length is going to change, your radiation pattern is going to change, means your current is going to change. Input impedance is specified generally R plus JX. R is a resistance and X is a reactance. It is a basic thing, we already know that. This is your input impedance for a thin dipole. These graphs you can search on any book, okay? And this is your real impedance, this is your imaginary impedance. What is going to happen for a very small dipole antenna? Because now you can change the length, lambda by 4, lambda by 2, lambda by 8, any length you can pick. But what is going to happen if the small dipole antennas are there? The input impedance is capacitive. Note down that, which means the impedance is dominated by negative reactance value and a relatively small real impedance or resistance. Now what is going to happen if dipole gets larger? The input resistance increases along with the reactance. This is very important. At slightly less than 0.5, the antenna has zero imaginary component to the impedance. That's why half dipole is very important, because at high dipole only your reactance is going to be 0. And this is what? When your reactance is 0, this condition is nothing but your resonant condition. So to achieve resonant condition, it is very important that you have to use half dipole antenna. Why half dipole antenna is very important? Your reactance is a zero and you are capable to get a resonant condition, that means maximum power transfer condition. Without any loss of signal, you can receive signal efficiently.
For more information of this topic, don't forget to subscribe my channel Pinnacle.